Bismillahirrahmanirrahim. Assalamualaikum. My name is Amna Fyal. I am Department of BS Biotechnology. Today my presentation topic is hydrogen fuel. Introduction. Hydrogen fuel is a clean and sustainable energy source that can be used to power various applications including vehicles and electricity generation. It is produced by extracting hydrogen from abundant resources such as water or natural gas. Compared to conventional fossil fuels like gasoline or coal, hydrogen fuel has key difference. Fossil fuels release carbon dioxide and other harmful pollutants when burned, contribution to air pollution and climate change. Additionally, hydrogen can be produced through renewable methods such as electrolysis, powered by solar or wind energy, further enhancing its sustainability. And now move toward the next slide, and the next topic is properties of hydrogen. First is high energy content per unit mass. Hydrogen has a high energy content, making it an efficient fuel resource. When burned, hydrogen releases a large amount of energy, making it sustainable for various applications including power generation and transportation. Next point is low molecular weight. Hydrogen has the lowest molecular weight among all the elements, which means it has a high energy to weight ratio. This property makes hydrogen an excellent choice for applications. Now move towards the next slide. Clean combustion. Hydrogen burns cleanly, producing water vapors as the only byproduct. These features make hydrogen a clean and environmentally friendly fuel as it does not release harmful pollutants or greenhouse gases into the atmosphere. Next point is versatility. Hydrogen is a highly versatile fuel that can be used in a variety of applications. It can be burned directly in internal combustion engines or used in fossil cells to generate electricity. Hydrogen can also be stored and transported in various forms such as compressed gas, liquid, or through chemical compound in different industries and energy systems. Now move towards the next slide. And the next point is production of hydrogen. First of all, electrolysis of water using renewable energy. This method utilizes electricity from renewable resources such as solar and wind to split water into hydrogen and oxygen. Electrolysis involves passing an electric current through water, causing the water molecule to dissociate. This process produces clean hydrogen without greenhouse gas for hydrogen production. And next point is biomass gasification. Biomass such as agriculture waste or energy crops that can be converted into a gas through a process called gasification. This involves heating the biomass in a controlled environment with a limited supply of oxygen, producing a mixture of hydrogen, carbon monoxide, carbon dioxide, and other gases. The hydrogen can be separated and used as a fuel. Now move towards the next slide. Steam reforming of natural gas. This method involves reacting natural gas, primarily methane, with high temperature steam to produce hydrogen gas and carbon monoxide. This resulting mixture, called syngas, is further proceed to separate hydrogen. Steam reforming is most common method for hydrogen production. It relies on fossil fuels and generate carbon dioxide as byproduct. Now move towards the next slide. And the next point is storage of hydrogen. First point is liquid hydrogen storage. And the first point is challenge. Hydrogen liquefaction requires extremely low temperature, resulting in high energy combustion and significant heat losses during storage and transportation. This solution is improved cryogenesis insulation techniques such as better insulation material as vacuum jet storage tanks, help minimize heat losses and increase efficiency. Advanced in liquefaction process contribute to reducing energy consumption. Now move towards the next slide. And next point is solid state storage material challenge. Finding material capable of safely and efficiently adsorbing and absorbing hydrogen at ambient condition and releasing it when needed. Solution: extensive research is being conducted to discover and develop suitable solid state materials such as metal hydrides, complex hydrides, and carbon based material. These materials can be stored and release hydrogen through adsorption and absorption and more compact storage. Now move towards the next slide. Compressed gas storage challenge. Hydrogen has a low energy density, require high pressure storage tanks that are heavy and expensive. Solution: advanced composite material and improved tank designs have been developed to enhance strength and reduce weight. Additionally, advancement in compression technology have increased storage capacity and efficiency. Now move towards the next slide. Next point is fuel cell. A hydrogen fuel cell is an electrochemical device that converts the chemical energy of hydrogen and oxygen into electrical energy. It consists of three basic components: an anode, cathode, and electrolyte. First is cathode. The cathode is the positive electrode, also coated with a catalyst. Oxygen gas from the air is supplied the cathode. The oxygen molecule react with electrons and protons that travel through an external circuit from the anode. This process is called reduction. Now move towards the next slide, and the next point is anode. The anode is the negative electrolyte, typically made of a porous material coated with a catalyst such as platinum. Hydrogen gas is supplied to the anode, where it undergoes a process called oxidation. In this process, hydrogen molecules are split into proton and electron due to catalyst action. Overall, a hydrogen fuel cell operates by combining hydrogen and oxygen in an electrochemical reaction to produce electricity, with water being the only emission. Now move towards the next slide. Electrolyte. The electrolyte is the medium that allows the flow of ions between the anode and cathode. It is typically a polymer membrane or an alkyl substance. The electrolyte selectively allows the passage of protons, blocking the flow of electrons to maintain an external electrical circuit. Now next point is electrochemical. As the electrochemical reaction occurs, the proton from the anode pass through the electrolyte to the cathode. Meanwhile, the electron unable to pass through the electrolyte travel through an external circuit, creating an electrical current that utilized to power device or recharge batteries. Now move towards the next slide. Applications of hydrogen fuel. Hydrogen fuel has various applications across different sectors, including transportation, stationary power generation, industrial process, and more. First of all is transportation, and the sub point is cars. Hydrogen fuel cell vehicles use hydrogen to produce electricity, powering an electric motor. They offer zero emission transportation with longer driving range and quicker refueling compared to battery electric vehicles. And next point is buses. Hydrogen powered buses are being deployed in several cities worldwide, providing clean public transportation options. And next is trains. Hydrogen fuel cell trains are being developed and tested as an alternative to diesel trains, offering quieter and emissions-free operation. Next point is ships. Hydrogen fuel cells can be used to power smaller vehicles and provide auxiliary power for larger ships, reduce multimate emissions. And next is aeroplanes. Hydrogen holds potential as a renewable aviation fuel, enabling zero emission flight when used in a fuel cell or as a direct fuel. Now move towards the next slide. Stationary power generation, residential and commercial buildings. Hydrogen fuel cells can provide clean and reliable power for heating, electricity, and backup energy in buildings. Power grid stabilization. Hydrogen energy storage system can help balance renewable energy fluctuation and enhance grid stability. Next is industrial process. Refining. Hydrogen is widely used in petroleum refining process to remove impurities and increase product quality. Next point is chemical production. Hydrogen is a critical element in the manufacturing of various chemicals such as ammonia and methanol. Next point is steel production. Hydrogen based direct reduction process have the potential to significantly reduce carbon emission in steel making. Now move towards the next slide. Advantages and challenges. First of all, we discuss about advantages. High energy density. Hydrogen has a high energy content per unit mass, make it an efficient energy carrier. Fast refueling. Refueling a hydrogen fuel cell vehicle is comparable to refueling a gasoline vehicle, taking just a few minutes. Long driving range. Hydrogen fuel cell vehicles typically have a longer drive range to compare battery electric vehicles. Versatility. Hydrogen can be produced from various sources including renewable energy, natural gas, and biomass. Next is zero emission. Hydrogen fuel cells only produce water vapor as a byproduct, resulting in zero direct emission. Now move towards the next slides, and this is the challenges. Production challenges. The production of hydrogen often relies on fossil fuel resources, which can result in greenhouse gas emission. Scaling up renewable hydrogen production is a challenge. Next point is infrastructure requirements. Hydrogen fueling infrastructure is currently limited, requiring significant investment to establish a widespread network of refueling stations. Next point is storage and distribution. Hydrogen is a low density gas which requires specialized storage and distribution system that can be expensive and pose safety concerns. Next point is cost. Hydrogen fuel cell vehicles are currently more expensive than transitional internal combustion engine vehicles and BEVs, primarily due to the cost of fuel cells technology and limited production sale. Now move towards the next slide, and the next topic is latest research and develop. Next and subpoint is improvement catalyst for fuel cell. Research have been working on developing more efficient and cost-effective catalysts for fuel cell. For example, platinum-based catalysts have traditionally been used, but efforts are being made to reduce or replace the use of platinum with alternative material like non-precious metals or non-metal free catalysts. These advancements aim to enhance the performance of fossil fuel cells, making more commercially viable. And the next point is new material for hydrogen storage. One significant challenge in hydrogen fuel technology is efficient and safe storage of hydrogen. Research have been exploring new material and techniques for hydrogen storage. Some promising approaches include using metal hydrides, porous materials like metal, organic framework, carbon based materials such as graphite and chemical ammonia, and liquid organic hydrogen carrier. Now move towards the next slide. Advantages in production method. Researchers actively work on sustained and cost-effective approaches for hydrogen production. Advantages have been made in water electrolysis, steam, methane reforming, and biomass gasification. Integration of renewable energy resources such as wind and solar power into the production process as enable the generation of green hydrogen with reduced carbon emission. Overall, the latest research and development in hydrogen fuel technology has focused on improving fossil cell catalyst exfoliating innovative material for hydrogen storage and advancing production methods. Now move towards the next slide and the future outlook. Hydrogen fuel holds significant potential in reducing greenhouse gas emission and meeting global energy demand in future. As a clean and versatile energy carrier, hydrogen can be produced through various methods such as electrolysis powered by renewable energy sources or by reforming natural gas with carbon capture and storage. And next point is one key advantage of hydrogen is its ability to be stored and transported effectively, enabling its use across different sectors including transportation. Hydrogen fuel cells can be powered electric vehicles, offering long range capabilities and quick refueling times. Now move towards the next slide. Moreover, hydrogen can contribute to decarbonization the power sector by serving as a storage material for renewable energy. Excess renewable energy generated during low demand periods can be used to produce hydrogen through electrolysis, which be converted into electrical through fuel cells or combustion when needed. Next point is nevertheless, many countries and industries are already investing in hydrogen technologies and infrastructure. Government are implementing supporting policies and private sector companies are undertaking research and development efforts to accelerate the hydrogen economic growth. Next point is overall hydrogen fuel has promising prospect for reducing greenhouse gas emission and meeting global energy demand in future. Hydrogen can play a significant role in transition towards and low carbon energy system. Now move towards the next slide. Thank you. This is all about my slides about hydrogen fuel.